this. I'm going to quickly go through this. Great job introducing VRI. We've been working on it since '99 in Georgia, and we've taken a slightly different approach, or very, well, actually similar to what Dr. Sweet was pointing out. We're looking at, and we use the word dynamic as opposed to a static map. Dynamic meaning it's in real time getting feedback from the field to do that magic that you were saying, wow, but then is it affordable, that sort of thing. I like the wow part. We'll worry about the affordable later. I'm an engineer. I love gadgets. So our goal is something like this, a data portal, a dashboard, if you will, that will have information from the field, like soil moisture data. It'll have the VRI map for today on the screen for the grower. It will have some calculated irrigation recommendations for each of those zones. It will have crop growth stage. You may have one crop, you may have multiple crops in that field. And we'll have hopefully some good precipitation forecasts to put on there. And then that grower can, get my mouse. Nope. So you see below recommendations, you see approve. So the grower, we want the grower to approve it. And then we're going to, and we already have it set up, and the grower can hit download, and that automatically gets beamed out to the center pivot. The VRI controller waiting on his employee to turn on the system. We don't do any automatic start or anything like that, too much liability. But we do send that today's map, if you will, out to the controller ready to irrigate in variable format for today's conditions. Now, if he doesn't irrigate today, waits till tomorrow, he thought he might get a rain, we'll have a new map ready for him tomorrow, ready to irrigate. How do we do that? You got to have VRI controls, as Dr. Sweet mentioned. We got to create irrigation management zones, as he mentioned. But we would argue we want to go the approach of a high-density set of low-cost sensors in the field. This is a field we worked in, peanuts. You see the non-crop area. The water is not being applied there, but everywhere else. It's being applied, and everyone asks, what's the little white splotches? He had some planter problems, apparently. Those are bare spots. And VRI, Dr. Sweet explained that very well. Our little animation we created for decision makers. You know how smart our policymakers are, so we made it very simple so they could sort of see turning off over non-crop areas, over highways, speeding up over wet areas, turning off over overlapping pivots, maybe slowing down over a sandy area, or Brian, maybe you need to go back to that area and water it more frequently. You can take two different ideas on that. But as Dr. Sweet was asking, he's on his soapbox, he's asking, what data do we need to create these management zones? And we also wonder, so we're using farmer knowledge, bare soil images, EC from Veris, just like he showed, elevation from the farmer's RTK system on his tractor, to create hydrography, flow patterns, anything and everything we can gather on that field. We will use it within reason. And Dr. Velitas, the lead on this project, his graduate student, who's moved on now, but Camden Lawrence, developed an EC zone, EZ zone, management zone creation tool that takes in all that data, takes into account your equipment size and things like that, and generates nice management zones. We use our our smart sensor array that we've come up with. It's wireless, it's low cost, energy efficient, uses 2 AA batteries all season, low profile, easy to install and remove. It's basically watermarks in the form of a probe with, like you have, antenna that tractor can go over. So there's our whip antenna, same idea that Swede just showed. We just happen to use a CB antenna mount to hold that. Doesn't always work perfect, but most of the time. The probe is easy to install and remove. Remove is sometimes more critical than install. When a farmer calls you and says, I'm harvesting my corn tomorrow, get the sensors out of the way. So Brian, you probably experienced that.
We did a lot earlier.
We've lost sensors before. We've worked for years to get this so that it sends data from the field using mesh radios in field to a single point, either at the center of the field or on the field edge. Then use a cell modem to get that to our website. We used to host it internally. Now I think we're using a commercial site, maybe GoDaddy or something like that. It FTPs it over. Our software is suitable for smartphone, tablet, or PC. We have the gauges, as you see Adam here looking at, full to empty. Or you can drill in and see the graphs of soil moisture. For watermarks, which are tensiometric, high value is dry. So in Georgia, I've heard a lot today about wait till you get to 100. We would never wait to 100 in our sandy soils. So we irrigate at about 40. So you can see the variability in this uniformly irrigated 200 and something acre field. You see how much variability was in there. We were not doing any variable rate at that point. So since then, we have worked further on tying tensiometric data using the Van Genooten model. I always mispronounce that. We had a grad student work on that, linking tensiometric data to actual inches required in that soil, depending on depth, to bring it up to field capacity. So very quickly, I'll just mention a test that we did the last 2 seasons, 2015 and 16 in peanut. We set up these strips. We first mapped the field and developed all our zones, as I described earlier, and as Dr. Sweet showed in his field. Then we created these strips of uniformly irrigated, as Dr. Sweet did, but ours were in strips as opposed to pie-shaped sections. The uniform strips were irrigated by the grower following the USDA Irrigator Pro irrigation management software. The other strips were obviously irrigated using VRI, using our soil moisture data. You can see how those laid out. They were large strips, 120 rows of peanut, the first strip. And then we basically weighed all peanuts harvested in each strip. We didn't use a yield monitor to develop the yield data that year. Got to have a UAV flyover in everybody's presentation these days, so there's ours. And what I want you to see, you see some sprinklers off right there, that's a zone that is turned off, and then you get a little further to the non-cropped area, and you see all those are off, turned off there, and then it resumes back on the other side. But this is a large field, very large. So for 2015, we did very well. We got essentially the same yield, and we used 3 inches compared to 4.3 for Irrigator Pro. Why that little amount of irrigation? We had 22 inches of rainfall during the growing season, so it pretty much was supplemental. We beat Adam in wet areas. We had a yield advantage there. He beat us in dry areas. So we really think the Irrigator Pro software is doing a good job really looking at the crop physiology throughout the growing season. Now, on the left is our zones, how we let soil moisture vary. And on the right, you see how Adam kept it. He kept it saturated. He's a good grower. He makes great yields every year. That's what he felt like he needed to do. But you can see his inches applied versus ours in different zones. And that is from that very first pair of strips in the left of the image. Just 2 of the strips shown. 2016, we moved to another field, even larger field. We again mapped the field, set up strips. These were 168 row strips. And again, VRI versus Irrigator Pro uniform irrigation. I should point out, the field is so large, it takes, I think it's 72 hours to make one pass. So there's no way we can trigger separate from Adam, the farmer. So we have to tag along with him. So if he irrigates, then we're going to irrigate ours based on our prescription map. However, sometimes we did choose not to irrigate any of ours based on our data when he was irrigating. So it's not a perfectly designed system, but for a farmer system, it's about as good as you can get. And I'll wrap up there with the data. We did not beat his yields in any of the zones. We were about 1.6%, 1.6 inches less in irrigation, but he beat us by 440 pounds per acre in yield. But you see our note there, the state average was 5,000 or less. Adam killed it, but so did we. So we feel like, you know, we did okay with a stupendous grower. We beat him on irrigated water use efficiency, and we had tremendous yield. If we compare ourselves to, say, Joe average, we'd probably beat him. So that's our small consolation there. But we think we've got something here. We're continuing to work on that. That just showed on the skip now some soil water retention. So that's our goal, is to get this tool. We're working with Advanced Ag Systems, who now sells what's formerly known as the FarmScan VRI system. They've done a great job of integrating a lot of things we needed, like remote upload of the VRI map. And we continue to work on this. We're using it again this year. And like I said earlier, we think that's a real photo from not far from us near the Flint River. We think we've got a tool for both policy reasons, and we do think for agronomics we've got a good tool. So that was quick, but there's our contact info, our website. We're down in deep southwest part of the state. So any questions for Sweet or myself? It's cool stuff. Bottom line, cool gadgets, but we do have to work on the economics.
Is GPS required for the business?
Absolutely. It's got to know all these maps we've shown, the system, whether it's doing VRI by speed control or VRI by zone control, it's got to know where it's at in the map versus in reality, where am I at right now, and what do you tell me to apply on each zone. So yes, part of the VRI has GPS, shielded out on the last tower, near the last tower. Yeah, that's kind of a given.
Anyway, if you practice precision ag, you got to have GPS.
Yes, good point.
Yeah,
That's a given.
So your zones are static, it's just the amounts you put in those zones are dynamic.
Yes,
But-
good point. They are static for this season. We are seeing some slight variability, not from EC, but maybe from previous yield maps. We're just seeing slight changes, and we can't really explain it all.
But in reality, if you had two zones, and one time you irrigated them differently, and the other time the same, you actually changed your zones too.
We're pointing out those details,
But,
right?
I mean, that's good, right? It is dynamic zoning,
Yes.
if that would
Yes.
happen.
And I did point out, since we're chatting now, we want 2 or 3 of those watermark probes per zone. You really need one, more the merrier, you can average them, but sensors fail, especially if you're doing low-cost ones like we are, so it's good to have backups.
How can you feel that you've picked equal areas to compare with the farmer to start with the yield potential those areas have?
That's certainly a consideration. If you were an editor of this document, you would say that. And we're just doing the best we can to try to pick similar enough areas. Absolutely. It's not a perfect
We
comparison.
do the same thing, it's like, well, we.
I mean, we feel like that's eons better than this field, VRI, this field, convention. But it's not perfect. Good questions.
Well, how about now? I have a question for you. You said you use the irrigation.
We do.
How?
I'm
Well,
a co-author, so you need to talk
Well,
more
you
about
have
that.
EC, you have irrigation. I mean, you have 2 parameters. How you use those 2?
I'm not
You
sure.
have multiple. You have more.
I would venture a guess, but
I'm not sure. You need to talk to George.
Well, elevation could, even though you have the same E someplace, you could have all the elevation coming down into the drainage.
I know.
And we
But
have
how
sand
can-
depositing in these low
How
spots.
you have to have a model, have a formula to calculate
you know-
the rate.
Yeah, you got
And
it.
you know, a low spot that holds
No, no.
sand is not always dry. Just
I
because it's
know,
sand,
that's the
it's low, so it
What's
gets
the model? What's the
we love to discuss it.